Okay, fourth graders, today we are doing Module 5, Lessons 14 and 15. We're combining two of them because they're both lessons are about figuring out how we can compare two fractions. Okay? Our problem of the day is kind of an example of that. It says Jamal ran 2/3 of a mile, Ming ran 2/4 of a mile, and Lena ran 7/12 of a mile. Who ran the farthest? Okay, so we have to figure out who ran the farthest. Now, we know that Jamal ran 2/3 of a mile. Okay, and Ming ran 2/4 of a mile. Right off the bat, do you guys see any common numbers there? 2/3 and 2/4. What number is the same? Everyone?
2.
What? 2, right? Okay. So if I have 2/3 and I have 2/4, which one's going to be more? What's bigger, 1/3 or 1/4? Everyone?
1/3.
So what's bigger, 2/3 or 2/4?
2/3.
So who ran farther, Jamal or Ming? Who? Jamal. Good. Now, Lena ran 7/12 of a mile. 7/12 doesn't have any common numbers, but do you see any multiples that could be shared? Like Ming ran 2/4 of a mile. Could I make 2/4? Could I use multiplication to decompose that to equal some number of twelfths? What version of 1 could I multiply 2/4 by to make it some number of twelfths? Think to yourself, 4 times what equals 12? Everyone?
3.
So what version of 1 should we multiply by?
3/3.
Okay, so 2/4 equals how many twelfths? 6/12. So who ran more, Ming or Lena? Well, I know that 6/12 is Ming's amount, and that's less than 7/12. So who ran more? So who ran the furthest? Who ran the furthest? Everyone? Jamal. Very good. Okay, so do you see how we used what we know about units to make similar units or to compare similar numerators in order to figure out how to compare two or more fractions? You don't need to write this down, but let me just ask you really quickly. Which one's greater, 3 apples or 1 apple?
3 apples.
3/4 or 1/4?
3/4.
1/4 or 1/5?
1/4.
2/4 or 2/6?
2/4.
How do you know that 2/4 is greater? Because 1/4 is greater than 1/6. So therefore 2/4 must also be greater than 2/6. So if you have the same numerator, you can compare. You can also compare, I can write 3/4 like this, and I can write 1/4 like that. Do I have the same numerator there? No, but I have the same denominator. So as long as you have the same numerator or you have the same denominator, you know now enough about numbers where you can compare them. Yes? So today when we're comparing two or more fractions, our goal is to try to make it so that they have the same numerator or they have the same denominator. Okay? What fraction is shown in the first tape diagram? I know that two sections are shaded in. And how many units are there altogether? 1, 2, 3, 4, 5, 6, 7, 8. So what fraction is shown in the first tape diagram? Everyone? 2/8. What about in the second one? How many are shaded in? 4, right? And how many are there total? Okay, so it's asking us to compare 2/8 or 4/10. Now, is there any way I could make the numerators the same or the denominators the same? The answer is yes. I could do both in this case. Which one will have smaller numbers? Making the numerators the same. Because I can think to myself, I know that 2 times 2 equals 4, right? Do you guys agree? But could I multiply 2/8 times 2? No, that would change the value of it. I can only multiply by one number in the entire world where I won't change the value. What number is that? What? Sparsha, if I multiply by 2, does that change the value? What? Yeah. So I can't multiply by 2. I can multiply by 1, though. So what version of 1 should I multiply 2/8 by? Sanvi? 1/1? Okay, if I multiply by 1/1, what's 2 times 1? What's 8 times 1?
8.
Does that help me compare? No. What version of 1 should I multiply by that will help me compare? Zara?
2.
Over?
2.
Good. Because then I know that 2 times 2 equals 4, And 8 times 2 equals? So now, I'm comparing 4/10 with 4/16. What's going to be more? Think to yourself, what's bigger, 1/10 or 1/16? Everyone?
1/10.
So which one's bigger, 4/10 or 4/16?
4/10.
So therefore, we can say that 4/10 is greater than 4/16. But I want us to always use our original terms, or original versions, to write our answers, right? Because we have to show what's in the tape diagram. So your answer is that 4/10 is greater than 2/8. Do not write 4/16. You want to put it in the way that the tape diagram shows. If we want to compare 9/10 and 3/4, we again have to think to ourselves, could we make the numerators the same, or should we make the denominators the same? What do you guys think in terms of these numbers? We know that 3 and 9 are in the same fact family, right? So I could change 3/4 to a different version of 3/4. Our goal is to multiply by some version of 1 so that we end up with what in the numerator? I want to make the numerators the same. What number do I want in the numerator? Arna?
9.
Very good. So, what version of 1 would we have to multiply 3/4 by in order to get 9 in the numerator? Sparsh? Why can we not multiply by 3? Because 3 is not 1. Very good. So therefore, this shows that 3/4 is equivalent to 9, what? 9/12. So we can think to ourselves, 9/10 compared to 9/12. Well, how does 1/10 compare to 1/12? What's greater? Everyone?
1/10.
So how does 9/10 compare to 3/4? Anshul? It's going to be, read me the whole inequality sentence. Go. Say 9/10.
9/10 is greater
Yep.
less than
It's less than 3/4?
greater.
Well, I don't know. You said them both. Is it greater than or less than? What?
Greater.
How do we know?
Because
Because that's the greater than sign. Very good. This time we have 7/10, and we want to compare it to 3/5. Can I make the numerators the same, or should I make the denominators the same? Everyone? Okay. What is going to be the least common denominator? Least means smallest. Common means the same. What's the smallest number that will be the same if I have a 10 and a 5? Everyone? 10. So this time I have 3/5. And I need to multiply it by some version of 1 in order to get a different version of 3/5 where the denominator is 10. What version of 1 should I multiply by? Kaship? 2/2. Very good. So therefore, this shows that 3/5 is equivalent to 6/10, which allows us to compare. Now we can compare 7/10 to 6/10. How does 7/10 compare to 6/10, everyone? 7/10 is greater than 6/10, which means that 7/10 is greater than 3/5. Because 3/5 and 6/10 are exactly the same. They just have a different name. This time we have 3/4 and we want to compare it to 4/5. Is it easy to make the numerator the same? No. Is it easy to make the denominator the same? No. In all of the previous examples, we only had to change one of the two fractions. Sometimes if it's not automatically easier to make the numerator or the denominator the same, you have to change both fractions. And we can use rectangular fraction models to help us rename both fractions in order to make that happen. Okay? So let me show you. Go ahead and draw 3/4. You're going to take a rectangle and you're going to color in 3 of the fourths. Of course, we'll label it as 3/4. Then, similarly, you'll take another rectangle and you'll color in 4 of the fifths. Now, you guys will notice that my first rectangle, the lines go up and down vertically, and the second one, they go horizontal. Do you guys see that? Okay. Now, I'm going to overlap the two lines. I had 4 lines, or 4 sections going up and down, and I'm going to draw that over here. Did I change how much was highlighted in that rectangle? Yes or no? Yes or no, did I change how much was highlighted? Did I? Did I change how much was highlighted? No, I just cut it into smaller size pieces. I'm going to do the same thing. I had fifths going left to right. I'm going to do that over here. Did I change how much was highlighted? No, I just cut it into smaller size pieces. Now, my rectangle on the left is now divided into how many units? Let's take a look. 1, 2, 3, 4 across by 1, 2, 3, 4, 5. What size units do I have now? Everyone? 20ths. Good. How many of those 20ths are colored in? Well, I have 1, 2, 3 by 1, 2, 3, 4, 5. So what's 3 times 5? Everyone?
15.
So that shows that 3/4 is equal to 15 20ths. Did we change how much was highlighted? Did we change the value of the fraction? What version of 1 did I multiply 3/4 by to get 15 20ths? Sarah? 5 over 5. Very good. Now let's take a look at our rectangle on the right. We used to have 4 fifths. But now, do we still have fifths? What do we now have? What size units do we now have? Sparsh? 20ths. Good. And 4 of the sections used to be colored in, but there's way more than 4 sections colored in now, right? How many are colored in now? We have 4 across and 4 down. What's 4 times 4? So that shows that 4/5 is equivalent to 16 20ths. What version of 1 did we multiply by in order to get that? Everyone? So rather than compare 3/4 to 4/5, we can compare 15 20ths with 16 20ths. How does 15 20ths compare to 16 20ths? It is, everyone? Smaller. Okay, so how do we say it? Less than. So therefore, how does 3/4 compare to 4/5? It is less than. So this is an example where I show you how sometimes you'll need to change both fractions, not change the value, but change the name of it in order to compare. Did we end up with the same numerator or the same denominator? Everyone?
Same denominator.
Very good. You need to draw rectangular fraction models like this to show how you do it, okay? Sometimes if we have improper fractions, you'll notice we have 5/3. 5 is bigger than 3, so that's an improper fraction. And we have 7/4. It can help us to use number bonds to compare. If I have 5/3 and I take away 1 whole, I take out 3/3. Anshul, please focus. Once I take away 3/3, how many thirds are left? Everyone? 2/3. Okay. Now, if I have 7/4 and I take out 1 whole, that's 4/4. How many fourths are left? How many fourths are left, everyone? 3/4. So if I want to compare this, I know that these parts are the same. This is the same as this, right? So all I really need to compare is 2/3 to 3/4. Is it easy to make the numerators the same? 2 and 3? No. Is it easy to make the denominators the same? 3 and 4? No. So that means that we need to use rectangular fraction models. So if I have 2/3, I draw a rectangle, I divide it into thirds, and I color in how many of it? 2 of those sections. Very good. Make sure it goes up and down. Okay. Next, give me a quick second. Okay. Next, I have 3/4. So I'm going to make these ones go right and left. And I'm going to color in 3 of them. Okay. Now, if I were to overlap those lines, I'd have to draw these lines like this and these lines like this. Do you guys agree? Did I change how much was shaded in? Did I change the value of any of those fractions? Okay, but now my rectangle on the left, it doesn't show 2/3. What fraction does it show? Sanvi? 8/12, very good. So what that shows us is that 8/12 is equivalent to 2/3. Now, Varsity, our fraction on the right used to show 3/4. What does it show now? 9/12, very good. So, if we know that we're comparing 5/3 to 7/4 with everything we've done so far, work with your table group. Which one is greater than? Or is it greater than, less than, or equal to? Go.